Thank you for joining us for this special moment. I want to take a moment to express my deepest gratitude to all the parents who have supported us. Today, I'm thrilled to introduce this wonderful group of students who have worked tirelessly.
Hello everyone, we are Yera, Junior and Eneko, students from DBH4, and today we are going to explain you the project that we have done during our second term in technology. Our model is inspired in a bridge from Bordeaux. Our project has three different parts. Firstly, we have the electronic diagram part, then we have the pneumatic circuit, and finally we have the structure that is mainly made of wood. Throughout the project, we faced different problems, mainly with the electronic diagram. Also, in addition, we did different things with paper and wood. You can see here that we did rocks with paper and a little boat that it have a light bulb.
Vale. As Eneko said before, a significant part of our project is the pneumatic circuit. This allows the bridge to lift the platform whenever a boat wants to go through or pass through. The pneumatic circuit is composed by a string that acts like a cylinder, and then there are two one-way bulbs. Now we are going to show you how it works. The circuit is quite simple. It has three modes depending on what you want to achieve. The first one is pressure. This lifts the platform. Now Eneko is going to show you how. The second one is empty. This distends the platform. And last but not least, we have repose, which is just to maintain. And this is all we are going to talk today about the pneumatic circuit. And now I'm going to let you with Yera, who is going to explain about the electronic diagram.
To finish off with our project, I'm going to be explaining how the electronic diagram works. The electronic diagram is used to light the light bulbs we've located in the upper area of the bridge. To light them, we use a push button that and it connects the whole circuit when it's pushed. We've selected white LED lights because we think it works with our model as well as we imagined. And the following step for next year would be having different LED colors depending on the type. For that purpose, we should take into account that different colors need different resistors. Thank you very much. And now we are going to show you how our LED lights work.
There is a button, and by pressing it, the lights turn on and off, depending. And this is it. Thank you.
We are going to take a little break and we'll prepare the following group. See you now.
Now we are going. Now we are going to continue with the second team. We are Gurutz and Ander, and we are going to explain you our smart city project. Our smart city project is a motorway toll with a crane that is simulating a car accident. The functional part of this project are the traffic lights and a servo that is a barrier. The barrier works with a ultrasound sensor. Uh, First of all, you need to put on the light, and then you need to get the hand near to the ultrasound sensor, and the barrier goes up and down. Uh, the traffic lights have three colors, and the model is impressed on 3D. Also, we have made a pneumatic system. It's a crane that is simulating a car accident, and it's functional when you push the syringes. It goes up and down. This is supposed to be an hydraulic system, but it's too expensive, so we can't afford it.
For the electric diagram, we used an Arduino working as the operator, then connected with three LED lights, a push button, and some resistors. The LED lights are connected with the resistors. That way, we prevent damage by lowering those ohms to 100 ohms by limiting the current. And then as we've seen, when you press the push button, the barrier gets up. That's because the servo is also connected, but with the servo and the ultrasonic sensor, we didn't need any resistors, so it was way simpler to connect them. We could improve this learning situation by maybe adding a parking lot with a counter or another traffic light. That will mean another 3 LED lights. For the electric diagram, we added a separate platform, a wooden platform. That way we keep our project cleaner. So this has been our presentation. I don't know if they want to ask any questions.
What was the most difficult part of your project?
In my opinion, the most difficult part of the project was to make the program functional, because we have a lot of difficulties making the servo work, because it wasn't compatible to make the traffic lights and the servo work together.
Yeah, I would say programming was the most difficult part, because we had a lot of parts that needed to work in the same time. So we've been quite in trouble, but we figured our way out. Thanks.
Thank you so much.
Thanks to you. So that's it. I think thank you for everyone at home.
Hello, we are Alain and Uxue, and we are going to present to you our technology class project. We must create a part of a small town where we have to introduce the things that we learned in the previous classes. And for that, we did some research and take different ideas. And finally, we thought to do a roundabout with 3 street lamps, as you can see here. And this system automatically turns the lights on whenever it's dark and turns the lights off whenever it's enough light. And these automatic street lights are useful in public places, roads, and parking areas that are the places where the continuous manual operation is not practical. And that means that they do energy conservation by ensuring that the lights only work when it's necessary. And after that, we started to bring up to life the idea that we had. And for that, we first painted the wood and give an appearance to our project with a little car and 3D printed lamps. And finally, we worked on the program and the Arduino that my teammate is going to talk to you about.
To continue with the presentation, we are going to explain the electronic diagram. To build this system, we use the following components. The first component is the LDR. The LDR senses the ambient light level and changes its resistance accordingly. When there is sufficient light, the LDR has low resistance, allowing minimal current to turn on the light. And when the light decreases, the LR has more resistance. And which triggers the circuit to turn on the LEDs. And the next component is the LEDs. These act as the street light, providing illumination when needed, and this located inside the street lamps. The third component is the resistors. A 100 ohm resistor is used to limit the current for the LEDs, and a 10,000 ohm resistor ensures proper voltage division in the circuit. And the fourth is the Arduino that provides the required voltage and current for the circuit to function correctly. And the last is the breadboard that facilitates connection between the LDR, LED, resistors, and Arduino, and distributing power and organizing the circuit. And that's all. And that's our project.
What was the most stressful moment during your project?
I think the program.
I also think the program or connecting all together because we didn't have a lot of idea during the project, but that's what the most difficult part.
Thank you so much for your answers.
Thank you.
Thank you so much for your answers.
Thank you.
A little break, and we're coming with the following group. Thank you.
Hello, we are Toña and Izaro, students from DBH4 from DBH4, and today we will explain you our project. Last year we did this amazing and beautiful house, so this year we have taken advantage of it and complemented it with 2 LED lights and 2 push buttons. To make that, we have made a project and an electronic circuit that I will explain you to now. We have assembled an electronic circuit that has 2 main parts, the inputs and the outputs. In our case, we have 2 inputs that are the 2 push buttons, and the connections are not as simple as they seem to be. As you can see in the diagram at the back, it needs a resistor that in our case has 10,000 ohms, and as long as you mount this diagram, there is no any problem, but the problem starts when you don't mount it and the noise comes out. In the output, we have 2 LEDs, and the connections are more easy than the inputs. We have 1 LED in the dining room and the other in the bedroom, and as I said before, the connections are very simple, and we have to take it into account that the anode has to be connected to the positive and the cathode to the negative.
In order to the software of our project, we have made a program using Arduino blocks. Our program is made in loop. That means that the same thing is repeated constantly. So, as Izaro has said before, we have 2 outputs and 2 inputs that play a really important role also in the program. First of all, the program waits until the button in the pin 11 is pushed, and when this happens, the LED connected to the pin 3 or that is also connected to the push button switches on. Then the program waits half a second and until the push button in the pin 11, so the first push button, is pushed again, so the switch, the LED switches off. After this, the process is repeated again, but in this case with the second push button and with the second LED. And then I must say that our program is quite long because it is the same thing is made twice, because we wanted 2 LED lights and to switch on and off in a specific order with each 2 push buttons. In conclusion, we must say that at the beginning we thought that it would be easy, but we have realized that there is a very long process behind the 2 lights and 2 push buttons, but we are very happy with the work we have done. Do you have any questions?
Which project did you like the most? This one or the one from last term?
I must say that there were very different projects, because this was a house and the other one was a car, so I can't choose because we have made different things, so we can't compare.
And Izaro?
The same, but I think that I like the more this one than the other one, but it's quite difficult.
Thank you so much.
Thank you.
Okay, so there is one group left. With the break and we finish today's presentation. See you now.
Hello, we are Egoi and Intza, and now we are going to explain our project. To do our project, we choose to make a model that looked like Ondarroa. We choose to do the part of the old town, that is, we put the old bridge because we think that is one of the most special bridges of the town. Also, at first, we thought about putting rowers in the sea through 3D, but it didn't work out.
The first step in this project was to design, and we used wood to work in the project. We painted and we shaped it. And then having everything ready, we started with the electronic circuit. This circuit measures the temperature and the humidity, and we followed several steps to do it. We use the sensor DBH4 that is for humidity and temperature. It has a thermistor for the temperature and a humidity sensor for the moisture. It works with an Arduino that uses one data pin for communication. It works with 3.3 voltage to 5 voltage power, and it works when measures between 0 degrees and 50 degrees, and when the humidity is between 20% and 90%, and it changes the data every 1 or 2 seconds. And for next year, we think that we can improve the project installing a ground ground measure, and like that, it works like a humidity sensor, and it will be something easy. And that's all. This is the DHT11 sensor.
What was the most difficult part to make in your project?
For me, the most difficult part was making the program, because I think that it's not easy to make a program, and was something new for me.
I think that the program is the most difficult because there is not easy to to program. So
Did you like it to learn how to program?
no.
Thank you for your sincerity.
Okay, so we have finished for today. Tomorrow we will have more presentations, the other group. Thank you and congratulations to all the students. Bye bye.